Hello everyone, welcome to my new science called physics class. In this class, we are going to discuss motion. Motion is very important topic in physics where we discuss the movement of object from one point to another. There are various forms in which an object can change position. Another way to define motion apart from movement from one point to another is changing position. So motion is not just taking something or something moving from one point to another, but also a way of changing position. So that would lead us to a classification or types of motion. We want to understand this. Physics generally is subcategorized into, or topics in physics are categorized into either topics under mechanics, or topics under electricity, or optics. This motion is a topic that is under mechanics. What is mechanics? Simply something that has to do with mechanical things, something that has to do with motion, energy, and all that. Energy that that can be used to do physical work. That physical work or that physical activity all are being studied in, or that is something that you can see with your eyes, moving, increasing, supporting. All of those things are studied as a group of similar things that are called mechanics. So the umbrella term for anything that has to do with object, physical object, moving something heavy, all those things are under mechanics. So motion is one of the important topics in physics that falls under this category that we call mechanics. Then others are optics. Under optics, everything that has to do with lens, mirror, glasses are studied under optics. Then electricity is an umbrella term for some sort of topics in physics that are dealing with electricity. All these mechanical or mechanism of working of electricity, how generator operate, how everything that has to do with electricity is being studied under electricity. So let me just put it this way. So now let's define motion. If we say motion, we can define motion by putting two important terms, which are location and position. Location and position, or let me say orientation, position or orientation. So for an object, for you to say an object moves, it must either change location or orientation. Let's start with location. Location, as we drew this in our previous class, we said that this is y, this is x. If you have something like this and this is 0, and an object moves from or an object moved from this point to this point, there you can say this object has changed its location from this point to this point. So this change of location, this movement, this change of location is movement, which is termed motion. Another thing is when you have a fan. Let's say you have fan. Oh, this is too much. So let me just do it 3 blades. You have fan. When fan rotates, then it change its orientation. Let's say you label this blade A and this is B and C. Later, you now saw this is C, this is A, this is B. Then this rotate or this change orientation. So this is another form of motion. So you can define motion in terms of location, changing location from one point to another, or change in orientation of the object. So now, since we know that we can have motion in terms of location or position, then now let's list the types of motion. Types of motion. Types of motion, we have 4 to 5 different forms of motion. The first one is the simplest one, which is translation. Translatory, sorry, I said translation, is translatory motion. Translatory motion is a type of motion where an object change location from point A to point B in a straight line. Change position from point A to point B in a straight line. If you do not put straight line, then you miss almost 50% of the definition. Is motion, let's say, is a form of motion where an object moves from one point to another in a straight how do you write straight? In a straight line. In a straight line. This is what translatory motion. Example of translatory motion is when you move from Kano to Katsina. Is translatory motion, even though there are bends, but we can consider them as translatory motion because we are using resultant. We talked about resultant yesterday, displacement yesterday. Let's say here is Kano and this is Katsina. So this is where you go and enter Katsina. So this motion, even though there is bends all over, but you also you'll also consider, or you always consider, displacement. So instead of using distance, we say displacement. Even though the object moves somehow to Kano, to Katsina, I mean, but still is translatory motion. So moving from a city to another city is translatory motion. Then movement from, let's say, from down to up, for example, I don't know, no matter how you transport yourself, but if the line is straight, then it's translatory motion. Then the next types of motion, the next type of motion is we have random. When we say random motion, it's a type of motion where an object moves without specific direction. The object moves with no specific direction. Let's say it started this point, but it moved this way, come back this way, and do this way, do that, do this, do all this form of irregular. The key thing here is the motion, the direction is not regular. It changes direction and you cannot predict the next direction. So this is random motion. When somebody tell you random something, that means there is no specific pattern for you to guess, or there's no pattern that will help you to know what will come next. You cannot predict the next something that can come. So that is random motion. Then the next types of motion, or the next type of motion is rotational motion. Rotational motion is another type of motion, or is one of the types of motion where an object rotate instead of now changing position. Remember, all these two types of motion, this one changes position or location from point A to point B. Again, the second example, random motion, the object moves from the original point here to somewhere, but there is no specific direction and it goes into different direction. So that one also is change in position. But this rotation is like the one we gave example with fan. If this is a fan and these are the blades, so if this blade rotates, then you have rotatory motion. Oh, I don't know how to draw very well. So if fan rotates, then the rotation is another type of motion. It's another type of motion where the motion is in form of rotation. So this is very important. Then the next type of motion is oscillatory motion. Oscillatory motion, when we say oscillatory motion, it's another type of motion where the object, let me write it, oscillatory, let me write it very well, oscillatory motion is a type of motion where the object oscillate, that is vibrate. So instead of it to move from one point to another, it keeps going and coming back. Let's say this is the point, starting point, and the object go to another point. Let's say this is A and this is B. So the object move from point A to point B, then it come back again. When an object goes and comes back, then the types of motion exhibited by the object is called oscillatory motion. Or instead of the oscillatory, you can also say vibratory motion. What people say call vibration is just simple this oscillation. When something oscillate, then it produces vibration. So you can say vibratory motion or oscillatory motion. This is the same thing. Oscillatory motion or vibratory motion are the same thing. It's not different thing. So oscillatory motion is type of motion where an object moves back and forward. They said to and fro. When object move to and fro, then this object is in vibration. Example of vibratory motion is when you hang. Let's say this is a ceiling. Let me orient you. When you have something like this, and somebody draw something behind like this in physics or in science generally, that means this is very rigid something. This is very strong something that can hold a load, for example. So I can just put something here and hang a rope down. Let me put blue and hang a rope down and attach a stone. Let me put stone as black and attach a stone. This is hanging from above. I can displace this. I can push from this side and displace this object to this position where it comes this way, and this is my stone. I can push it to this position. But when I release the pushing force, what will happen to the object? Then the object can go back, but when it goes back, it will not stop here. It will reach up to this point, maybe here. Let's say maybe this point. Then you have movement of this object from this point to this point and then back to this point, and this movement will continue to and fro movement, and this to and fro movement is what constitutes vibration, and it's called vibratory motion. This setup is called simple pendulum. So if you want to know more about this, follow us in our next in our subsequent videos. We are going to discuss more about simple pendulum. So this is very classical example of vibratory motion. Another example of vibratory motion is when you have water. Let's say this is water. This is let's say bowl of water, and there's water inside here. Everywhere is water. This is water, for example. So then you put a test tube. Let's say this is an empty test tube. Let's say this is an empty test tube, and you find some things. You load the test tube. What is loading? Just to take something from outside and put into this test tube. This is loading the test tube. So you can load the test tube by putting some sand. Let's say sand or stones. You put some stones, and this is water. When you drop this into the water, it will not submerge completely into the water. But if you just drop the test tube like this, and the test tube enters the water, it would not go completely into it will not submerge, but it will stay and it will be dancing up and down, because the load is not enough to push the test tube into the water to make it submerge. So the test tube will remain oscillating up and down. Let me put the 2 arrow here, up and down. So this up and down movement of this test tube will constitute what is called oscillatory motion. So in essence, oscillatory is just a type of motion where an object change position or change let's say change position or location, but it still comes back to the initial position. This is for pendulum, and this one is for test tube, loaded test tube. You can produce similar effect using a wheel. Let's say this is a wheel, and let's say you just mark a point here. But let's say this is not actual wheel. Let's put the center here, and let's say this is not real wheel, but this, from this center to this point, you attach a stone. From this center, let's say it's rigid, and you attach a rope to and attach a stone at the other end. Then you make this, you throw this forward just to make it rotate around your hand or around this point. Then you will create another oscillatory motion, because this stone can go to this position and can come back to its original position. So this is simple explanation of vibratory motion, even though this one is looking like rotatory motion. But this one, this rotatory motion is the types of some of the earlier phones. I don't know for the smartphones now, but for the earlier phones, especially Nokia, they use this kind of setup to produce vibration. They have their motor. Let's say this is, let's look at the head of the motor. This is the motor which can rotate something, and this is the shaft that can be, okay, let me draw it this way. Let's say this is the motor, this is the motor, and this is the shaft. From the motor, it has a shaft, and this motor can rotate this shaft. So then they make one, let's say this is let's say this is something like this. Let's say this is a cycle, this complete cycle, and this is the center of the cycle. If this rotates, then everywhere would be all the this block or this round object, this cylinder can rotate, and there's no the force will be balanced. It will just be rotatory motion. There will be no vibration. But what they do is they cut this off and leave this as half of it, and they attach this half to this motor. Let's say you just attach this half here. You will best appreciate it in this view. So when this move, the movement of this motor will make this what do you call it now, half of this cylinder to rotate. It would assume different position, this position and this position, and also to the other position, the other side. Then it is going to produce vibration when this motor spins very fast. So this is how they produce the vibration. So vibration is just that is a form of motion that an object goes and comes back. So now we discuss these 4 types of motion. We have sometimes 5 form of motion, which is the last one, which is relative motion. Relative motion is types of motion, is just normal translational motion, but now you are comparing 2 different things. So that's why sometimes they are not considering this as a standalone types of motion. They use for you to understand this, it's just like you are on the road and there is 2 cars. Okay, let me draw it this way. This is the road, so this is the middle. So you have 2 cars. You have 1 car here and you have another car here. This car is the fastest, no, it's the one that is in front, and this car is moving faster than this one because it is now reaching and even want to overtake this car. So let's assume this car is moving 100 kilometer. Let's say let's label them as A, or let's say here is B and this one is A. So car A moves in 100 kilometer per hour, while B moves with 120 kilometer per hour. So now if somebody is in car A and the next person or the observer is in car B, now he will come and overtake the car A with what speed? Or the car A, somebody in car A will see this car B overtakes them with what speed? So now since both of them are moving, this same person that is in car B will see that, yes, is in car A will see that this car B will pass with velocity of 20 kilometer per hour. Why? Because they are both moving, and this car B will only pass with speed of 20 kilometer per hour because initially this car A is not static, it's also moving. But when this car is observed by somebody here standing, he will see that, okay, this car B is moving with 120 kilometer per hour. But in car A, if somebody is in car A, will see that the person or the car B is moving with 20 kilometer per second. This is very important for you to understand. So this is the simple analogy that will help you to understand. And the analogy is when you are in a bus, very long bus, and this bus is moving with 50 kilometer per hour. 50 kilometer, let's say, let me just write 50. Okay, let's say bus as bus. So the bus is moving is moving with 50 kilometer per hour. Now you in the bus, you move to the back seat from the door area. You move to back seat. As the car or as the bus moves with 50 kilometer per hour, you in the bus, you move back with speed of just 2 kilometer per hour. So now your speed, your actual speed, because your speed now, because the bus is moving with 50 and you are coming back to the back seat with 2 kilometer per hour, then you cancel some of the speed of the car. Now the car is almost like it's moving faster than you when you compare somebody that's on the ground and both of you. So the observer in the car or in the bus will see you as you are moving back in speed of 3 kilometer or 2 kilometer per hour, while somebody outside the car will see you moving with speed of 48 kilometer per hour, while the bus is moving with 50 kilometer per hour. For you to understand this, I need to put it in practical so that you people should understand it better. That is why this lesson is the theory part of the lesson. We have practical part where you appreciate all these examples more. So at least we discussed theoretically the theoretical aspect of motion, its types and examples. In our next lesson, hopefully we will discuss about the practical aspect of it, or in physics practical we'll discuss the practical aspect of it. Hope you enjoyed this lesson. If you do so, as always, please like our videos, comment, put your question there. We are going to see them and answer you. Also share our lesson to people who need these kinds of lessons, and also subscribe, open notification button so that you get notified every time we upload a new video. And if you want to join our WhatsApp group, this is the phone number. Remember, WhatsApp as always, because most of times we are busy. So message us in this number or through this number 081 28 14 18 16. See you in the next lesson. My name is Science School. We always wish you success. Thank you.